So, hi, I'm Danny. This is Miguel. We both work here at New Relic. We are part of the database team, and our team works on the charting library that powers most of our products. And today we're going to talk about an aspect of the charts that we do, and it's the loading state. Up until now, we had this loading state. It has nothing wrong. In fact, it's built in Sass. It's pretty nice. It's customizable, the number of dots, the radius, the color. But we are moving into something different. This is the design that we got from our designers. It's a new placeholder that will... So this is the new loading state. And this is a pattern that is pretty common on lazy loaded images, for example, and also on other sites, like in the Facebook news feed. So at a glance, this seems pretty simple to implement, but there is a catch, and it's that we have many charts at New Relic of many sizes and many different aspect ratios. So this pattern needs to adapt. And for example, if the chart grows vertically, we need to have more placeholder ticks on the y-axis. So we sat down and thought about the different approaches that we could take. The first one is using a background image. We could use a PNG or something, but that doesn't really scale, and it can be animated unless we use a GIF, but that's for cats, obviously. We could use box shadow and try to replicate the placeholder, but that's quite complicated, and it won't repeat endlessly as we need. And finally, we could use canvas, but that's too complex and too overkill. So we finally decided we will do it with SVG. There are three ways we could use that SVG. The first one is in the HTML, but that adds a lot of repetition, and it's not that clean. The second option is generating the SVG in JavaScript, but doing this every single time for every chart is quite bad for performance. And the last one, and that's the one that we choose, is to have the SVG embedded in our CSS. So we are generating the SVG in Sass. So that means that the SVG is built once, and then it's cached with the style sheet and the rest of the styles. So this means the code is cleaner, and what we need to do is what we need it to do is accomplished here with it's scalable and it's adaptable, and we can animate it. So now Miguel will explain how we actually constructed the SVG. So do you have any questions up until now?
Okay, so let's move on. Cool. So once we took the decision of building the SVG, the placeholder by using SVG, we started analyzing it. And basically, we can see, as Danny was mentioning before, when we thought about the box shadow approach, within the placeholder, we have clearly two patterns that repeat. We have one for the y-axis that goes from the top to mostly the end of the placeholder. And then we have another one for the x-axis that repeats horizontally. So the first thing we needed to do is to divide our SVG into two blocks to apply to each of the parts one pattern. So these are the two blocks. The blue one will be related to the y-axis, so a pattern that will repeat vertically, and the green one will apply to the x-axis. So once we know more or less how we're going to face the problem, we have to actually position different layers in order to put the pattern on them. So here comes the first problem that we had to figure out, which is about positioning. So the problem is that you have to position the box aligned to the bottom of the SVG, And the problem comes on the fact that the SVG coordinate system creates the 0, 0 on the top left corner. This means that depending on the size of your SVG, you cannot position it directly just by taking an absolute value from the upper left corner to align it always, to stick it to the bottom. So analyzing the different positioning options you have in SVG, and especially related to the y-axis, you can either use the y attribute of SVG elements, like rects, lines, patterns, etc., or you can use the transform one with the translate y. Each of them has its own advantages and inconvenience. Namely, y can both accept percentages and pixels, but you cannot combine more than one unit. So you cannot have things like a calc inside the y attribute. While on the other side, translate y allows you to put many values by putting many translations. The problem is that you can never specify percentages inside it. You can do it in CSS, but you cannot do it in SVG. So the solution we came up is combining both. So we first apply a y of 100%, so we pull the box down outside, and then we pull it back up by using a transform of a translate y of minus the height of the box. So when you combine both, what you get is a box that is always aligned to the bottom, no matter which size the SVG has. So this allowed us to create the green box we showed before for repeating the pattern for the x-axis. The second problem is also related to sizes, but it comes from the upper box, for the blue box. The problem is that we need to create a box that goes from the upper left corner, so from y equals 0, towards the bottom, minus the height of the green one. So it's again the same problem. In our case, we solved it by using, that is a bit tricky. We first use a height of 100, and then we pull the box up with a translate y of minus the height of the box that it's below. The truth is that, as you can see, the box goes out of the canvas. But thanks to the fact that the SVG, which is the root, like the viewport, will clip the image, the result is that you get more or less an image you get a rect that goes from the top to your bottom, no matter which size your SVG has. So with these two tricks, we have two boxes correctly positioned. And now it's time to fill them with the two patterns that will create this illusion of the repeating ticks for the axis. So this gives us for the patterns. So as we said before, we have the pattern A, which is the one for the y-axis, and then we have the pattern B, which is the one that repeats for the x-axis. As you can see, the pattern is not only the placeholder, but also we added some extra space so that when you repeat the pattern over and over, we create some space in between them, because otherwise there will just be one after the other, and you will just see, in that case, you will just see a thick white box. So same thing applies to that one. We create some space here, so when the pattern repeats, we create a gap between one placeholder and the next one. Also in that case, since we want this pattern to scale as much as big the SVG is, we had to combine percentages and pixels. So as you can see, this rect, this is for the y-axis, so the horizontal line. The rectangle has its width defined in pixels because we don't want it to scale. So the starting line starts at 52, which is actually 3 pixels more than the width. This is just to give it like some space. But the ending line is set to 100%. So when the pattern repeats, this coordinate will always be fixed at 52 from here. But that one will extend no matter how big the SVG is, which is what we want to achieve. If we don't do that, at some point we will cut the pattern and it will start repeating over. So a similar technique applies for pattern B, but that one is simpler because it always keeps its height. So once you have the patterns, you basically apply these patterns. We'll see that at the end, but you basically apply the SVG patterns to both boxes, the top one and the bottom one. And when you do that, you end up with something that looks good. But when you scale, it does something that is really weird. Actually, as you can see, when the SVG increases its height, basically what is happening is that the pattern, which is repeated infinitely in the viewport, it gets cut. And you basically get just like as if it was a window over the pattern. This is not what we want to achieve. And the reason on why this happens is because SVG patterns repeat from an origin. And by default, the origin is the origin of your coordinate system. In our case, the coordinate system starts at the top left corner because it comes from the SVG. So basically, when you stretch down the SVG, you're just cutting the pattern, and it doesn't look good. So this is basically the code for the pattern as we saw it before. And what we did for fixing it is to change the place where the pattern starts repeating. So by default, patterns start repeating at 0. That is the attribute, the Y attribute. So once you switch it to 100%, what you say is that your origin for repeating the pattern will not be the upper left corner, but the bottom left corner. And once you do that, basically you get this. And when you scale the SVG, both patterns are kept on the right place. Actually, the pattern styles, let's let it go down again. The pattern starts repeating from here towards the bottom, but since the pattern repeats indefinitely, it also repeats towards the top. And what we're actually seeing is just the repetition of the pattern just above it, which de facto works as if it was a background position with 100%. So now that we have both placeholders, so both patterns representing the placeholder, the last thing we had to solve is how to implement the gradient. So I don't know if you notice it, but on the first slide where we showed the full design, there was kind of a gradient that looked like this. So it's a pattern that gets repeated endlessly towards the left, and it appears like it's moving. So the first thing we tried is just by creating a gradient that starts on blue, goes to white, then back to blue, and we try to animate it. However, we have to create this illusion of endless movement. So this didn't work. And what we actually did is to duplicate the pattern. So actually, the gradient we have looks something like this. So starting from 0, our pattern, the pattern that you can identify that it's moving on the first one, goes up to 50. And once you reach 50, from 50% to 100%, we just repeat the same pattern again. So then what you do is that you just animate the pattern, the gradient, going from 1 unit, so 100% on the left, to 100% on the right. So something like this. This is actually what is happening. So the pattern goes from the left side to the right side. And since the pattern is duplicated, once this half reaches the viewport, then the viewport has the same thing as it had at the very beginning. So you can just start over the animation and you don't notice any cut. So actually, if we take the bottom one and we strip out and we just crop the canvas, you can actually see that there is no trick. It's just the fact that once you don't notice that the animation is getting repeated over and over, your eye just thinks that it's an endless animation. So with this thing, we created the illusion of an endless pattern moving. Just for taking a look at the code, this is how the code for the gradient looks. So actually, the gradient doesn't go from 0 to 100, as we said before. It goes from 0 to 50, and then it gets exactly repeated from 50 to 100. And then what we do is that we animate x1 and x2, which are the attributes that say when the pattern has to start and when it has to end, from -100, which is 1 unit towards the left, to 0, which is just the left of the viewport. And then we animate the x2 from just the right of the viewport to 1 unit beyond the viewport, which is basically this. So that one goes from minus 100 to 0, and that side goes from 100 to 200. So assembling everything, so we've got the patterns, we've got the rects that will pull the patterns in, we have the gradient. The only very last thing that we have to do is to use this pattern that we have created to clip the gradient. So building the full SVG, this is how it looks like. So we have the SVG, then we have the definitions. Inside the definitions, we have both patterns. We have pattern A and pattern B, which is the pattern for the Y and the X axis. And then we create a mask in SVG. We apply, this is the blue rect and this is the green rect. So we apply the pattern for the Y-axis to the top rectangle and the pattern for the X-axis to the bottom rectangle. This creates a mask. And then we have the linear gradient. And combining everything is just done with a rect that is over all the SVG. This rect has actually an X and Y of 0 and a width of height of 100%, so it fully covers the SVG. It is filled with the gradient, and it's clipped with the mask that we just created. And this all together is actually what creates the illusion of the gradient moving, no matter which size the SVG has, which is what we wanted to achieve. So this looks good, but this is all SVG, XML actually. And as we said, we wanted to have that inside CSS. So Danny will tell us how to do that. But first, do you have any questions? Nope. Aitor? Oh yeah, they're gonna give you a mic.
This is gonna be slow.
Toma. Ah.
Hi. Yeah, works. I probably wasn't following as I should have to. But how do you make sure the number of lines in the y-axis is going to be an integer? Basically, how do you make sure you're not making a line and a half or something like that in the pattern?
That is a really nice question. Actually, we don't. When we started analyzing this, we had two options. First one was to fix the amount of ticks both in the y and the x-axis and distribute them evenly. So no matter which size the SVG had, we always had the ticks exactly positioned. Option B was to repeat the pattern as much times as needed, which you do by changing the user units, user on space units. I can't remember exactly now the name of the attribute, but you have to change which units do you use inside the pattern. And then, sorry, you can let the browser know that you want to repeat it as much. So talking with design, you have a really good representative of Neuralix design here. They decided that it was better to keep the distance between ticks consistent. So actually, this means that if you can cut in half one of the patterns. So if your SVG measures up until like this, you will cut the tick by half. Which, to be honest, is something that happens in our charts nowadays. Any other question? Okay, so Danny will let you know the secrets about how we added this in SVG, in CSS.
Okay, so this is how we would add the final SVG to our background image in CSS. As you can see, we have many problems here. It's not very legible. Even the syntax highlighter has gone completely crazy here. And everything is hard-coded. It's not dynamic, so we can change any of the attributes of the SVG. and we use those ugly backslashes for enabling multi-line strings. So what we wanted to do in Sass, this could have been done in Less or any other preprocessor, but we use Sass here. We want it to be dynamic. We want to tweak the colors, the sizes, positions, and be able to also tweak the animations however we want. Next thing is reusability. We will be having more placeholders like this one for other types of charts. The pie chart, for example, will have a different placeholder. So we want to reuse the tooling that we have created around this placeholder to easily adapt it to new charts. And finally, and obviously, it has to be a clean code and structure. So our first move was to create a mixin, and this mixin will hold the variables for our SVG. These are, here you have the math and the measurements that we use across our SVG. So anytime we will be able to tweak this, and the generated SVG will adapt. We have also moved the gradient into a function that receives two parameters. The first one is, this is for the gradient, the initial one, the initial color, and the second color, and also the duration for the animation. So as you can see, everything is then interpolated into the string. Here is the function for the gradient and the values here on the top. Okay, this is a first move. It's better, but we still have the problem with the backslashes and everything hard-coded. So we thought it would be great to have a Sass mixin that will help us generate SVG nodes in Sass. So this is what we thought would be a good fit, a mixin that takes the first argument, the type of node you want to create, and then a map with the attributes and values for that node. It also has to be able to nest children within parent nodes. So basically, this is an example for the pattern we have, where we have included the SVG mixin with a pattern, and within that pattern we have the line and the rect. I won't go into details onto how the mixing itself is built, because it's very Sass specific and quite complicated to follow. But the thing is, this is what is rendered afterwards. It's valid XML, and we have our pattern with our two lines and their attributes. So we have to mention also that we are escaping XML and encoding for that data URIs straight from the mixin, and afterwards on build time we are using an SVG optimization tool to basically remove everything that's unnecessary that gets generated from this mixing. So that's it. Thank you. Questions?
Yeah, I have a question. I'm no CSX expert, you might know. Why would you choose Sass instead of some JavaScript helper that just injects the result into your Sass file afterwards? I mean, is that the usual approach, to have all this logic into Sass mixins, or just you felt very courageous this day?
It's both things. We felt courageous, but that's something we explained at the beginning of the talk. We also wanted to create this on build time. So it generated once, and then it's cached and used everywhere else.
I mean, your build pipeline is JavaScript.
Uh-huh.
So.
But most of the CSS and JS solutions are at runtime, so I guess this is the point of them.
Okay, well, might make sense.
Well, actually, I think that what you're saying is that you would use a script at build time that creates this in some sort of a compiled CSS file.
Just asking. I don't have an opinion.
The thing is that for doing this kind of dynamic things with CSS, which are not truly dynamic because at the end they end up being compiled in a static file, but things like variable interpolation, reusing mixings, etc., we already use Sass. So what you would expect for doing things like this is to use the default tooling that we use for creating these things. The truth is that we had to come up with a way of declaring the SVG in a Sass way, but I would say that this is the rightest or the raider approach compared to having a custom pipeline that creates with JavaScript a CSS file that then gets concatenated into the main one.
I mean, it's clever. I never thought about using Sass this way, so well done.
Thank you.
Great work for the braceholder.
Thank you.
But what happens when the chart is ready to appear on the screen? How do you reveal the chart? You have any offset problems with the lines? Because probably the chart has different scales.
Okay. Yeah. So this is something I also asked design about it. So basically, to put the problem into context, this is a background image that gets built in. It builds up on a class, and we just add this class to the container that it's loading the chart while the chart loads. Once we reveal the chart, we get rid of this class, and we basically clean the background in order to plot the chart. So when this happens, actually, the place where the ticks are put does not match with the place where the ticks are on the real chart. So we did two things here. First is we can't make them exactly match. And the reason is even if we built the placeholder with JavaScript, we don't know things like what's going to be the maximum Y of the chart. So we cannot know in advance how many ticks are we going to plot, where are they going to be located, etc. So it's something we can't solve on that side. What we did, though, is we kept all the sizes of the small ticks mark, the size of the text, and the standard width that our bar has on the y-axis. We kept it as is on the SVG. So it's true that they don't match exactly, but you don't see a big jump. Because all measurements of things we know in advance, like text height and stuff, they match perfectly. So at least the x-axis does not jump, for example.
Okay, aren't you worried that you made the mixing and it's reusable and it's super nice, but aren't you worried that it gets actually used that much that it will generate megs of SVGs inside classes? And okay, that's cached, but is it better actually than having a little script that just generates that on runtime? I mean, about performance, I'm talking. I mean, if you use this mixing like 20 times, you will get a huge amount of CSS, I guess, right?
This is partially right, but not completely. So this mixing, it's true that if people uses this for no matter which SVG, they will end up creating a lot of XML code that will relay will impact on the final size of the CSS file. There are two buts to this. First one is For things like icons, we already do that. Most of the times we have scripts that, they go to a file and they just process the file and they include the file pretty much entirely inside the CSS. So that's not a big issue we're worried about. Second thing about the size, it's true that so one of the goals of why we did this is because we've just shown you how to create these, this pattern for what is like a B-scalar chart, X and Y axis. However, what the design team wants is they want to apply this to other patterns like a pie chart when the result is going to be a pie chart, or a histogram, vertical bars when we're going to get this kind. So the shape will kind of mimic the expected chart. And for that case, most of the code that we use will be repeated over and over. So the gradient will always be the same. And it's true that you will end up with the gradient repeated many, many, many times on the CSS file. The thing is, thanks to gzip and the deflate algorithm, you will get rid of all these repetitions by assigning a code that is really small. So the final size of the SVG, the CSS that will be transferred over the network, will not be that big. And one really cool thing we did here is that we don't base 64 encode the image. We just keep the SVG as is by encoding 2 or 3 characters. So this allows to recognize, pretty large patterns and shrink them into, very small deflate codings. So the SVG file will not be as big or much bigger than what they already are nowadays.
I will add that you don't expose that mixins to the consumers because you're building a framework and consumers just render charts, but they don't need to use Sass. So I think it's not a problem in that case.
Yeah, that's actually true. Like the UI team has already built their own pipeline for incorporating the icons. We create the placeholders using SVG, but apart from that, I think no one at the company is required to create these kind of background images, because either we provide them as the library, as the charting library, or they use the ones from the infrastructure UI team. So yeah, that's true. Actually, the mixing is not exposed on the package we create. Cool. So no more questions? Good. So thank you.
Thank you.